Hi Math 3 students. Let's work practice benchmark chapter 9. Now chapter 9 is arithmetic and geometric sequences and series, and we did go over a little bit of this in math 1, and we did talk a lot about the arithmetic sequences and how they are related to the equation of a line and slope. If you'll notice, I know this one's arithmetic because there's no exponent like the geometric sequence and series. So when we look here, I can tell that this is arithmetic because it's linear, and it's very related. If you can see, the number next to the x is the slope, and this is the y-intercept. Now, if we look at a basic explicit formula, we know it's a sub n equals, and then you have your first term plus the number of terms minus 1 times the common difference. Now it doesn't look like it's in this form, but if I distribute the common difference and then simplify with that first term, I end up looking like an equation of a line. So the arithmetic sequence is very related to an equation of a line, just like the geometric sequence is very related to an exponential function. All right, so let's generate the first 5 terms using this explicit formula. All that means I have to do is plug in 1, 2, 3, 4, and 5. So if I plug in 1 here, I'm going to go -2 times 1, which is -2, plus 3. So my first term is going to be, let's go first term, second term. My first term will just be 1. Now my second term, I'm going to plug in 2 here. 2 times -2 is -4 plus 3. And I'm going to get -1. Plug in 3, 4, and 5. So we need the first 5 terms. So when I plug in 3 times 2 is -6 plus 3, and I'm going to get -3. Plug in 4 times 2 is -8 plus 3, and that's going to give me -5. And plug in 5, and 5 times -2 is -10 plus 3 gives me -7. So there's the first 5 terms of my sequence. One thing I want you guys to realize, when you're using the explicit formula in its regular form, not in this form where it's simplified, this form, if I plug in a 0 term, I get my y-intercept. But in the other form, I start with my first term, and that's often confusing because before I simplify, I'm dealing with my first term, not my 0 term, which can give me a y-intercept if I was graphing a line. Okay, so what is the 15th term of the sequence using this formula? Here's an explicit formula in its reduced form. So I'm just going to plug in 15 for that number and then subtract 1. 3 times 15 is 45. 45 minus 1 is 44. Simple enough. Okay, let's write a recursive formula for this sequence and then find the next term. Now let's go ahead and look and see if we have a common difference here or maybe a common ratio. So let's see. From 7 to 13, 13 to 19, 19 to 25. Well, let's go. I know 13 minus 7 is going to be 6. So I take my second term and subtract my first term to see what I add to get here. And then 19 minus 13 is 6. Once again, take the second term and subtract the first term to see what you add. Let's see, is 19 plus 6 25? Yep. 25 plus 6 is 31, yep. So the common difference is 6. A recursive formula, we know the recursive formula is any term, you take your previous term, the one previous, so any term, you take the previous term and you add the common difference. That's all you do. But you have to know where to start. So you start with 7. And then from there, you take any previous term, and so if I want this term, I take 25 and I add 6. And that's all it's telling you. What are you adding? Take your previous term and add the common difference. So my recursive formula specifically for this sequence, because I know the common difference is 6, I know my first term is 7, and then any term, I have to state my first term, otherwise the recursive formula doesn't work because you don't know where to start. The explicit formula will work without stating the first term, but the recursive formula, you need to state where you start, because then I take any previous term, and I add on 6, my common difference. So if I want to find the next term, I take my previous term. So this is 1, 2, 3, 4, 5. I want to find the 6th term. So the 6th term will equal 6 minus 1, the 5th term, plus 6. Well, this is my 5th term, so 31 plus 6, which is 37. So here is my recursive formula. You have to state where you start, and then you take your previous term and you add the common difference. And the next term in this sequence is going to be 37. Okay, to the next one. Okay, we did the recursive, now the explicit that helps us find any term. So the explicit formula, let's first of all make sure this is arithmetic. From 9 to 11, if I go 11 minus 9, I get 2. So 9 to 11, I add 2. If I subtract these, I get 2. To get from here to here is 2, here to here is 2. Yep. All right, it looks like I have a common difference of 2. Now my explicit formula, any term I can find by doing this, taking my first term plus whatever the number of terms I had minus 1 times the common difference. So to get from, like, let's say 1, 2, 3, 4, 5, to get to the 5th term, I would start with my first term and I would add the previous term, the number of terms minus 1, to get to the 5th term. I would do it 4 times the common difference. So I'd add the common difference 4 times. 1, 2, 3, 4. Now multiplication is the same as repeated addition. So I multiply the common difference times 4 times. I do it 1, 2, 3, 4 times to get to the 5th term. So let's make it specific for our sequence. Any number that I want, I start with my first term, which happens to be 9, and I add on n minus 1 times that common difference of 2. Now, if you want to simplify this, you can leave it like this. This is totally fine. If you want to do it in the simplified form like they had up there, you distribute the 2. So this would look like this, 2n minus 2. And then I add it to 9. So I have 9 plus 2n minus 2. And 9 and 2 combine to make 7. So 9 minus 2 is 7. So I'd have 7 plus 2n. And an would equal 7 plus 2n, or you could write it like this, an equals 2n plus 7. Now it looks like a linear equation, my slope and my y-intercept, and your slope would relate to your common difference. So you can give it to me in this form, or you can give it to me in a reduced form, either way. If I want to find A14, I'm going to go A14 is 2 times 14 plus 7. 2 times 14 is 28 plus 7, 35. So the 14th term is 35. On to the next. Okay, this is asking me if the sequence is arithmetic, so I need to find a common difference if it is. So I'm going to go 19 minus 14. That's going to give me 5. So 14 plus 5 is 19. 24 minus 19 is 5. 29 minus 24 is 5. So there is a common difference. So yes, and the common difference is 5. Let's look at this one. Let's go 21 minus 14, and that gives me 7. So 14 plus 7 is 21. 42 minus 21, that is not 7. I'm going to stop there. I know I'm already done. This is 21. Okay. Now, if I wanted to do a division and see if there's a common ratio, I could, but it's just asked me if it's arithmetic. I already see it's not. Nope, done. Find the 110th term of this sequence. Well, to get from -7 to 3, I'm going to go 3 minus -7. That difference is 10. From 3 to 13, that difference is 10. 13 to 23, that difference is 10. So I do have a common difference of 10. Now, I'm not going to do that 110 times or 1, 2, 3, 4 less than 110 times. That's crazy. Instead, I'm going to go ahead and write a sequence, an explicit sequence. Explicit sequences, remember, any term is you take the first term plus the number of terms minus 1 times the common difference. So any number of terms is going to be my first term negative 7 plus the number of terms minus 1 times my common difference of 10. Now to find the 110th term, A110 will be negative 7 plus 110 minus 1 times the common difference. So if I do 110 minus 1, that's going to be 109 times 10. And then I'm going to go ahead and subtract 7. And this amount here is going to give me 1083. This is the 110th term. So use your explicit formula to figure that out because you don't want to count that out. That is where this would be useful in real life terms. If you need to figure out what happens later on if this keeps occurring this way, explicit formula would help figure that out. It's also good just for understanding reasoning and patterning. Okay, find the second and third terms of this arithmetic sequence. Since it's an arithmetic sequence or arithmetic sequence, to get from here to here, I can see what the common difference would be because I have 2 in a row. So I'm going to go negative 27 minus 22, and I can see that difference is negative 5. So to get from here to here, I subtract 5. So to get from here to here, I'm going to subtract 5. So from negative 7 subtracting 5 to get to my next term, I'm going to get negative 12. Now the next term, I'm going to subtract 5. So negative 12 minus 5 is going to give me negative 17. And double check it, make sure negative 17 minus 5 is negative 22. And if it is, you did it. So negative 12 and negative 17. Now find the missing term of the arithmetic sequence. Now we don't have 2 in a row, but we do have 1 in between. Now there's something called the arithmetic mean, which it's just like finding the average, the middle term. So I'm going to add these two and divide by 2. 26 plus 18 and divide by 2. Now when I do that, I get 22. 22 will be the number in between these. From 26 to 22, I subtract 4. 22 to 18, I subtract 4. So that does give me a common difference. And it works. Okay, Viola makes gift baskets for Valentine's Day. She has 13 baskets left over from last year, so she starts with 13. Let's just write that down. She plans to make 12 more each day, so you could go 13 plus 12, and then just add 12 each time, right? And you could do that. If there's 15 work days till she begins to sell the baskets, you could do that 15 times. Add 12, add 12, add 12. Or you could just go ahead and let D equal the number of days and just do a little equation, arithmetic sequence. You start with your first term of 13 and you're going to add on 12 each day. So 12 more baskets times the number of days. All right, that's how many baskets she'll sell. So I'll put B for baskets to sell. We'll equal this. Now she has 15 work days, so you just plug in 15 for your D or for your number. 15 times 12, let's go ahead and do that. That's 180. So I'm going to go 13 plus 180, and that will be my number of baskets. And add that together, my number of baskets will be 180 plus 13 will be 193. And that's it. Pretty simple. Okay, on to the next. Okay, geometric sequences is what we're dealing with next. We did arithmetic sequences. Let's go ahead and see if these are geometric. If they're geometric, they have a common ratio, and we can figure out by taking term 2 and dividing it by term 1, because then that will tell us what we multiply to get to term 2. So I'm going to go 24 divided by 6, and that gives me, it's negative 24, so that gives me negative 4. 6 times negative 4 is 24. Is 24 times negative 4 96? Let's see. 24 times 4 is 96. Is 96 times negative 4 negative 384? It is. So is this geometric? Yes. What is the common ratio? Negative 4. All right, check this one. I'm going to divide this by this. So negative 4 divided by 2 is negative 2. So then I need to see, that is my first common ratio. Is it common all the way through? Well, excuse me, -4 times -2 is, if I did it again, -4 times -2 is +8. And I get -16. With geometric sequences, I can't stay negative because you're doing multiply. It would have to go positive, negative, positive, negative. And these are staying negative, so I can already tell this is a no. There is not a common difference. Okay. What is the fifth term of this geometric sequence? So we have 1, 2, 3, we need 4, 5. Now I can do a series, or excuse me, I can do a formula here, or I could just count this one out because it only asked me the fifth term instead of like the 110th term, which I would want to do a formula for sure. But the fifth term, since it's a geometric sequence, I go 15 and divide by 5. So if I take 15 and divide by 5, I'm going to get 3. So I know to get from here to here, I multiply by 3. Okay. And then to get from here to here, I'd multiply by 3 again. So instead of writing out a formula, since I only need to get to the fifth term, I'm going to go 45 times 3 and get to 135. And then I'm going to go 135 times 3 and get to 405. Now you could do a formula here. And the formula, the explicit formula for geometric sequence, any term, is going to be your first term times your common ratio to the n minus 1 power. So here our first term is 5. Our common ratio is 3 to the n minus 1 power. So if I wanted any term here, I would say I want the fifth term. So I would go A5 is 5 times 3 to the 5 minus 1 power, which is 4. Well, 3 to the 4th power is 81, and then multiply that by 5, and you're going to get 405. So not necessary to do this because they only asked you the fifth term. If they ask you for the 100th term, you definitely do that. Okay, they want an explicit formula for this geometric sequence and then find the fifth term, which once again, because it's only the fifth term, you could just count it out. But let's see, we have the first term is -4. Second term is 8. Third term is -16. To find the common ratio, I take the second term, divide by the first term, and I can see that common ratio is going to be multiplied by -2. Multiplied by -2, that looks like a plus. Sorry. Let's erase. Times by -2, and then to get from here to here, I would times by -2. So remember, explicit formula for geometric is any term is your first term times your common ratio to the n minus 1 power. So any term is going to be my first term, which is -4, times my ratio, which happens to be -2, and I'm going to put it in parentheses so you know that whole thing is in parentheses, to the n minus 1 power. So there is my explicit formula. Now I need the fifth term, so I'm going to go, well, A5 is equal to -4 times -2 to the 5 minus 1 power, which is 4. So -2 to the 4th power times -4. Well, let's see. -2 to the 4th power is 16. Then times that by -4. That's going to give me -64. So -64 will be the fifth term, and that is my explicit form. And I could have found that by doing this 2 more times. 16 times -2 is going to be 32, positive 32. And positive 32 times -2 would be -64. So once again. Okay, on to the next. Okay, this one wants you to find the values of the missing term of this geometric sequence. Since we don't have a second term, that's really hard to figure out what the common ratio is. But we do have 2, and we can find a geometric mean. Now, the geometric mean is a little different than the arithmetic mean. The geometric mean is found by multiplying the 2 terms together and then finding the square root of them. It's like squaring them and square rooting them. So, and when you square root, you always get a plus or minus solution. So I'm going to go 54 times 1944, and then I'm going to square root that. And let me square root 104976. And that is going to give me plus or minus 324. Just be aware when multiplying this term, these two are positive, but we don't know this term. It could have been negative or positive. If your common ratio was negative, it would go positive, negative, positive. So that's why you have to state it's either of these. So please be careful of that. All right, what's the sum? Let's go on to number 16. What is the sum of the finite arithmetic series? So we're going to sum now, and I always think series sum. So truly when you sum, you literally could just add up these numbers because it's a finite number. Or if the number of numbers is large, you could use the formula for the sum would be the number of terms divided by 2, and then you multiply that times the first term plus the last term. So if we do this, we have 1, 2, 3, 4, 5, 6, 7. So sum the first 7 terms. You would go 7 divided by 2, and then your first term would be 22, as long as they're in order. Yeah. And then your last term would be 52. And if you do that, 52 plus 22, and then multiply that by 7, and then divide that by 2, you're going to get 259. Now that works if you have a ton of numbers. These you probably could just add up on your calculator and you're going to get the same thing. All right, here we also have a finite number of numbers, but look, there's some spots. Okay, here we also have a finite number of numbers, but here we have some spots missing. So we don't know how many numbers that we need to sum. Here we could count out, we had 7 terms, so we knew our number of terms. Here we don't know our number of terms because we have some missing. Now I can see from 29 to 32, my common difference is 3. 32 to 35, 3. So I can go ahead and go 41, add 3 until I get to 59. Or I can go ahead and figure out the number of numbers. I need to figure out how many it is to get to 59. So what I'm going to do is I'm going to write an explicit formula for this. I know my explicit formula for, arithmetic series is AN is the first term plus the number of terms minus 1 times the common difference. Okay, the common difference is 3 and my first term is 29. So AN is 29 plus n minus 1 times 3. What I need to figure out is that number of terms. What is 59? What number is that? Well, let's simplify this in a simplified form. AN is 29 plus 3 times n is 3n, and 3 times -1 is minus 3. So simplify this. 29 minus 3, 29, 28, 27, 26. So 26 plus 3n. That is my explicit formula. Now I want to know n. That's a problem. What is my number of terms? I don't know that. What is my n? Question mark. If I knew n, I could just go ahead and use this formula. I'd go n divided by 2, and then my first term and my last term. But I don't know my number of terms because of this here. So I'm going to figure that out. I know my last term should be the end of it because it's finite. So I know that last term, that AN, is 59. So 59 will equal 26 plus 3. Now, I don't know what the number of terms is. I'm going to figure out what 59 is. 59 is the answer. What's the number of terms? Normally, I plug in the number of terms and it tells me it's 59. I'm giving you the answer and I figure out the number of terms. So I subtract off 26 from both sides. All right, so 9 minus 6 is 3, 5, 4, 3. 33 is equal to 3n. And then I'm going to bring this up here. 33 equals 3n. And then divide by 3 on both sides, and n is going to equal to 11. So the number of terms, this is the 11th term. Now that was a lot of work to figure out the number of terms. I had to write the explicit formula. I had to put in the last term to figure out n. What was that? That's the 11th term. Okay, so now I'm going to go ahead, and now that I know that last term is the 11th term, the only other way to do that, to figure out what that last term is is to count the common ratio over and over and over until you get to 59 and see how many spots are in between to get to here. Okay, so that's the 11th term. So now I'm going to go ahead and use this formula, and I'm going to go summing. There's 11 terms over 2, and then my first term is 29, plus my last term is 59. That's the 11th term. And now I can go ahead and do the math on this. 29 plus 59, and then I'm going to multiply that by 11 and divide that by 2. And I'm going to get the sum of 484. So this one's a little more intense when they don't tell you the number of terms. Use the explicit formula to figure out what number that is. All right, let's go on to the next one. Write the series. Here we go. Write the series in some summation notation for 14 terms. Okay, when you're writing in summation notation, you want to write where you start and where you end. Okay, and then here is your explicit formula. So 5n would be an arithmetic formula because there's no exponent. All right, and your first term here would be 0 because there's nothing written, right? So what we want is we want to sum in a summation notation. We want to start with our first term, and we want to go to 14 terms. Okay, and then we want to plug in our explicit formula here. So explicit formula, we need to figure out what is this series, okay? Is it arithmetic? Is it geometric? Well, let's go ahead and find a common difference first and see. 54 minus 49, that would be adding 5. 59 minus 54, that would be adding 5. So it looks like I have a common difference here of 5. Okay, so my difference is 5. Now remember, my formula for explicit would be any number of terms is my first term plus n minus 1 times that common difference of 5. Okay, so I'm going to plug in 5 for my common difference and my first term. 49 plus n minus 1 times 5. That is my explicit formula. Now simplify this before you put it here. You could go ahead and put this here, but simplify it. 5 times n is 5n. 5 times negative 1 is negative 5. So I'm going to have 49 plus this. Now 49 minus 5, that's going to be 44 plus 5n. So make it look nice and have the explicit formula be 5n plus 44 or 44 plus 5n. Okay, and then you start from your first term and you go to your last term. So you can check to see if this works. Plug in your first term, plug in 1 here, and see if you get out 49. So if I plug in 1 here, I'm going to go 1 times 5, which is 5. 5 plus 44 is 49. Plug in your 14th term and you'll get your last term in this. So what goes here is your explicit formula. Okay, and then you start with your first term to your last term. Now careful, when I start with 1 to 14, that's 14 terms. If you start with 0 to 14, that's actually 15 terms. Careful there. Okay, so I'm going to evaluate this series from n equals 3 to 8. Okay, now if I want to evaluate this series, okay, so I need to plug in my values to evaluate this series. I want to sum 5n when n is 3 to 8. Now one thing I could do is I could plug in 3, then 4, then 5, then 6, then 7, then 8. Or I could use the sum form and then I could add those numbers up, right? Or I could use the sum formula, summing those first terms. It's going to be n divided by 2, the number of terms divided by 2, times the first term plus the last term. Okay. Now the first term here would be when n is 3. So first I plug in a sub 3 into here. So I'm going to go 5 times 3. So that first term is 15. All right. And then my last term is 8. So I'm going to plug in a sub 8. And that's going to be 5 times 8. When I plug in 8 here, I get out 40. So my first term is actually 3. I start here at 3. My first term is 15. And then my last term is, when I plug in 8, is 40. So I'm going to sum the terms from 15 to 40. And then the number of terms, now careful, this is tricky. If you go from 3 to 8, you think your number of terms would be like, oh, 8 minus 3, which is 5. But you have to count that first term. Think about it. You have the third term, fourth term, fifth term, sixth term, seventh term, eighth term. 1, 2, 3, 4, 5, 6 terms, because you're including this term. Now 8 minus 3 is 5, but you're counting that first term 3, so you have to go 3, 4, 5, 6, 7, 8. There's 6 terms here. Okay, so that number of terms is 6. There are 6 terms from 3 to 8. 6 divided by 2, so sum that. All right, so 15 plus 40 times 6 divided by 2, if you work that all out, you're going to get 165. All right. Now, if you wanted to, you could just plug it in and write it out. That would look like this. I plug in 3, I get out 15, right? I plug in 3, I would go 5 times 3, I get out 15. Then you plug in 4, 5 times 4, you get out 20. Then you plug in 5, plug in 5, 5 times 5, get out 25. Then you plug in 5 times 6 and you get out 30. Then 5 times 7 and you get out 35. Then 5 times 8 and you get out 40. Okay, so that's what this summation notation means. You're summing it from when n is 3 to 8, and you're doing this formula to it, 5n. So I'm summing when n was 3, then 4, then 5, then 6, then 7, then 8. And then I would add all these together and I would get 165. All right, on to the next one. Okay, now this one, finding the sum of this finite geometric series, because this one's so small, it totally is easier just to add these up, truly. But just for the sake of doing the formula, the finite geometric series formula looks like this. When you have a finite number of numbers, you would go the first term times 1 minus the ratio to the n power over 1 minus the ratio. So first I need to know the common ratio. Well, 6 divided by 2 is 3. So it looks like 18 divided by 6 is 3, 54 divided. So it looks like your common ratio is 3. You have your first term and you have your number of numbers. 1, 2, 3, 4, 5, 6. So n is equal to 6. You can count it. So I'm going to go my first term, which is 2, times 1 minus my ratio, which is 3, to the n power, which is 6, over 1 minus my ratio, which is 3. And just do the math on this. This sums up the first 6 terms, n being 6. Okay, so the first 6 terms. So I'm going to go 3 to the 6th power, which is 729. So this is going to give me 2 times, and if I go 1 minus 729, I'm going to get a negative number, so it's going to be negative 728, which you want that to be negative, because look what happens on the bottom. 1 minus 3 gives you a negative 2, and then the negatives will cancel out. So I'm going to multiply that by 2, and then I'm going to divide it by negative 2. So this total will give me 728. All right, now add those all up and you should get the same exact answer. No, that might be easier. Okay, you want to sum this geometric series. It's in summation notation, round to the nearest whole number. Okay, now I want to go from 0 to 15, so I could plug in 0 for x, and then 1, and then 2, and then 3, all the way to 15, and then add those all up. But that would take a while. Let's use our summation notation. Okay, so summing the series for geometric is your first term times 1 minus your ratio to the n power over 1 minus your ratio. So we need our first term. We can figure that out by plugging in our first term. Since we're going from 0 to 15, our first term is going to be when x is 0. Now, we need our number of terms, and we need our ratio. So let's go ahead and figure this out. Our ratio, because this is the explicit formula, remember the explicit formula for geometric looks like this. Okay, So explicit would be your first term times your common ratio to the n minus 1 power. Now you could separate this and simplify this, but your ratio will be here and raised to a power. So look, your ratio is 1/2 raised to a power. Now 1/2 is going to converge, but that's not important just yet because it's not infinite, it's finite. But so your ratio can be easy to figure out. You can see it, it's right there. Now if you weren't sure, you could plug in your first term and plug in your second term and then divide the two and figure out your common ratio. Right? So there's your ratio. You need the number of numbers. Well, you're going from 0 to 15, so you would think that's your number, 15, but you have to include 0, that's a term. So 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 16 terms, one more. Okay, remember you have to count that term all the way till 15. There are 16 terms, all right? And now your first term you can figure out, plug in that first term, plug in 0 for x. So I'm going to go 2 times 1/2 to the 0 power. Anything to the 0 power is 1, and I get out 2, right? If you wanted to figure out the second term, that's when x is 0. When x is 1, your second term, you would go 2 times 1/2 to the first power. 1/2 to the first power is 1/2. 1/2 times 2 would be 1. Now you could figure out your common ratio to your second term divided by your first term. It's 1 divided by 2, or 1/2, which is right there. Okay, so that is your ratio. So there's your ratio, there's your number of terms. You have your first term. It's actually the 0 term, but it is the first term in this sum, this series. So plug it all in. I'm going to go Sn is my first term is 2. And I'm going to go 1 minus my ratio is 1/2. And then number of terms is 16, 1/2 to the 16th power, all over 1 minus my ratio, 1/2. All right, so I'm going to do this on a calculator. I'm going to go 0.5 to the 16th power, and that's a big number. And I'm going to go 1 minus that. And then I'm going to multiply that by 2. And on the top, I'm going to get this crazy number, 1.9999. How many 9s do I have? 1, 2, 3, 4, and then 69482. And I'm running out of room, but we're going to round anyways. And then 1 minus 1/2 gives you negative 0.5. All right, and then I'm going to divide that by negative 0.5. And the sum that I'm going to get is going to be, and this would be negative, by the way. Sorry, this was negative. Divide out the negatives, and the sum I'm going to get is 3.999999, which I'm going to round up to 4 when I sum this. So what's the sum of this? Rounded to the nearest whole number, it's 4. All right. Okay, finite numbers, meaning there's an exact number, it has an end, it's finite. Those are easy to sum, you add them all up. But infinite means it goes on forever. How do you add up a series that goes on forever? How do you sum that up? If this keeps going on and on and on and on, and I add it and add it and add it, it goes on for infinity. The sum would be infinite. But you can find a sum for infinite geometric series if it converges. Meaning these numbers get smaller and smaller and smaller and smaller till they're so small the amount that you add feels like nothing. Okay, that's converge. Diverge means these numbers get bigger and bigger and bigger. So converging means the denominator of your fraction gets so big that this number feels like nothing because it starts out at 1/5, then 1/10, that's a smaller number, 1/20th, even smaller, 1/40th. So basically your common ratio needs to be the absolute value of it. It could be positive or negative. It needs to be less than 1. It needs to be a fraction, less than 1. So if I'm looking at this, does it diverge or converge? Well, look, the denominator keeps getting bigger, which means this number is getting smaller and smaller and smaller and smaller and smaller. So since it's getting smaller and smaller, it's going to start coming to 0. So it does converge. Okay, it converges to a point. So I'm going to say converge. Okay, that fraction's getting smaller. Now this 3, then 9, then 27, then 81, then it's going to get bigger and bigger and bigger and bigger and bigger. So I'm just going to keep adding on bigger numbers. It diverges. It just blows up. Okay, this diverges. Okay, that's when your ratio is greater than 1. All right. If it's equal to 1, that would still greater than or equal to 1. If your ratio equals to 1, you just keep adding 1 forever. It's going to get bigger. Okay, so just remember it converges if you have a fraction here. I mean, the absolute value is, that absolute value of that common ratio is less than 1, which means you could have a negative or positive fraction. That will converge because if that, as that fraction gets bigger and bigger and bigger, as that denominator gets bigger, these numbers get smaller and smaller and smaller. So adding them together will feel like it comes to a point. Diverges if these numbers just get bigger and bigger and bigger. Then you'll never be able to add them up. Okay, let's go ahead and, so fraction, not a fraction. Let's go ahead and go to 24. Consider this infinite geometric series. Okay, write the first 4 terms. Does it diverge or converge? Okay, it's infinite. It goes from 1 to infinity. So if I want to write the first 4 terms, first of all, I can already answer this. Does it diverge or converge? Because remember, when it's in summation notation, this is your explicit formula. Remember, for a geometric series or sequence, the explicit formula, you start with your first term, then you go your common ratio to the n minus 1 power. This is your common ratio. It's right here. Okay, so 1/3 is your common ratio. It's a fraction. The absolute value is less than 1, which means it's going to converge. Okay, does it converge or diverge? It converges. I have a fraction for my common ratio. So it's going to get smaller and smaller and smaller. As this number gets bigger, this fraction becomes smaller. The number becomes smaller because the denominator gets bigger, which makes this number smaller. Okay, so I already know it converges. Write the first 4 terms. Okay, plug in 1 for n. I'm going to go -4 times 1/3 to the 1 minus 1 power, which makes that 0. Anything to the 0 power is 1. 1 times -4 is -4. So there's my first term. Okay, so let's go to the, that's plugging in 1. Now plug in 2. I'm going to go -4 times 1/3 to the 2 minus 1, which is 1. Well, 1/3 to the first power is 1/3 times 4. That's -4/3. Here's my second term. Let's go third term. I plug in 3 here, so I go -4 times 1/3 to the 3 minus 1 is 2. Well, 1/3 squared, that's 1/3 times 1/3, which is 1/9. Now you can see this denominator is getting bigger, which will make this get smaller and smaller. So 1/9 times -4 is -4/9. Now go ahead and plug in 4. You're going to go -4 times 1/3. 4 minus 1 is 3. So this is 1/3 times 1/3 times 1/3, which is 1 over 27. So 1 over 27 times -4 will be -4 over 27. So you can see this will get bigger and bigger and bigger. So there are the first 4 terms of my sequence. It does converge because this denominator gets bigger and that's going to make that number feel smaller. Okay. If the series has a sum, find the sum. If not, write no sum. Because it converges, those numbers are going to get smaller. I can find a sum. This is going to start getting so big that this number almost goes to 0. So I get to a sum. Now, if this was bigger than 1, I wouldn't get a sum. The numbers would go on forever. They're infinite. So it has a sum. I can find the sum. Here's how I find a sum for a infinite, going on forever, as long as it converges. I can find a sum. So the sum's easy. You take your first term. You don't know your last term because it goes on forever. And then you divide it by 1 minus the ratio. So the sum is going to be my first term, which is -4. And I divide it by 1 minus my common ratio is 1/3. Okay, so I'm just going to do this on a calculator. If I do 1 minus 1/3, oops, and that's going to give me 2/3, but let's just go ahead and do that. So negative 4 over, this is 3/3 minus 1/3, which is 2/3. Keep the top, flip the bottom, change to multiply. Remember, keep, flip, change. When you have a divide divided by another fraction, keep the top, flip the bottom, change the divide to multiply. So 4 times 3 over 2 is going to be negative 12 over 2. And this will be negative 12 over 2. And then 2 goes into 12 and gives you negative 6. So this sum, if I sum this for infinity, it's going to converge to the number negative 6, because as those numbers get so big, nothing really will be added to it. It will be so minuscule. It basically will come to the point where it's just about negative 6. All right, guys, that's how you do this. Let me know if you have any questions. Good luck. Have a great day.